In this video, we'll look at how JPEG achieves a lossy image compression while maintaining high image quality. The first difference between bitmap and JPEG files is color coding. Bitmap uses RGB values, while JPEG uses YCBCR values. We can view the conversion from RGB to YCBCR as a transformation of coordinate system in 3D color space. The main benefit of using YCBCR is that the Y value, which is basically the average intensity of RGB values, is more significant than the other two components. In this way, we can achieve a higher compression ratio by dropping some information about the two chromatic components. Since images will have different levels of complexity at different parts, it is preferable to split the image into smaller parts and encode each one separately. In JPEG encoding, the picture would be split into squares with side length of 8 pixels. Also, we'll treat the 3 color components separately. Let us denote a piece of image by a matrix S, where S of ij is the value of a color component at row I, column j. The idea of transformation is to convert a set of data into another set of data, which is a reversible process, so the original image can be obtained by applying the inverse transformation. The transformation used in JPEG encoding is discrete cosine transform, DCT. As a feature of DCT, the values in the top left corner are more significant than the values in the bottom right corner. Hence, we can reduce the data size in the bottom right in the next step, quantization. After the transformation, the resulting values would be real numbers in the large range. It would take up much space to store all of the values accurately, so we would apply quantization to these values. For different data of different importance, the quantization levels could be varied. For more important data, values could be rounded to nearest integers, while the rest of the values could be rounded to a rougher estimation. This is the step where information about the original image is lost. A quality factor can be introduced to determine how accurate the values would be rounded off. For a higher quality factor, there will be more quantization levels and the compression ratio will be smaller. After the above steps, the image processing part is over. Now, for each color component, we have a collection of 8x8 matrices. In each 8x8 matrix, the top left datum is called DC, while the rest of the data is called AC. DC and AC are compressed differently. As a consequence of DCT, DC values are in fact the average intensity of the original image matrix. Due to the fact that neighboring image pixels are generally similar to each other, the difference between neighboring pixel values are often smaller than the actual values. As a result, the difference between consecutive DC values is stored instead of the actual DC values. To serialize an 8x8 matrix into a binary file, a zigzag pattern is used. In this way, the data will be written in descending order of importance. If there are many consecutive zeros, they will all be replaced by the number of zeros. After these two steps, DC and AC values are compressed by Huffman coding. Huffman coding is theoretically the most efficient coding algorithm for file compression. The basic principle is that common code patterns will be mapped to shorter sequences, and rare patterns will be mapped to longer sequences. As a result, the overall file size will be smaller. DC and AC are compressed differently using two Huffman tables. Now, the file compression has completed. To render the image from a JPEG file, the reverse processes of the above have to be carried out. That's it. Hope you enjoyed the video.